It's important to note that you do not always have to have input arguments to a function. If you don't, then you can have, both in the function header and in the function call, empty parentheses, or you can just leave them out. And it doesn't matter if you have in the function header empty parentheses, you can still just leave them off when you call the function. So again, you don't always have to pass input arguments to a function. When you have a function, the function header and the function call have to match up. It's almost like a game, like a puzzle, to make sure everything matches up. The name has to be the same. So the name of the function is given in the function header, and it's also the same as the name of the M file in which the function is stored, and that's the name that you have to use when you call the function. The number of input arguments has to match up with the number of values that you're passing to the function. So if you have 3 input arguments in the function header, you need to pass 3 values to the function when you call it. And the number of variables on the left-hand side of the assignment statement should be the same as the number of output arguments if the function is calculating and returning something. So if the function is returning 3 values, you should have 3 variables to actually store all of the values that the function returns. And if there aren't any output arguments, the function call is a statement. Since it's not returning anything, you can't put that inside of another statement like an assignment statement or a print statement. Another thing that's important is that functions that return values, whether they return a single value or multiple values, do not normally print those values also. That is left to whatever called the function, for example, the script. So let's talk more about program organization. In a modular program, every task is implemented in a function. So in MATLAB, a program consists of a script, you can call that the main program, that calls functions to accomplish the task. At the very least, most MATLAB programs will consist of a script that calls functions to perform the basic algorithm, which is first step, get the input or inputs, whatever you need. Second step, calculate the results. And third step, display the results. So most MATLAB programs are going to consist of at least 4 different M files. The script that calls the functions, and then the individual functions that get the input, calculate the result, and display the results. And of course, you can easily imagine that that could expand to a lot more functions than that. Here's an example of a modular outline of a program. So here's an outline of a script that is going to call 3 different functions. So this is the script where X, Y, and Z are 3 different things. So this is our script that has 3 statements in it. First of all, it's calling a function named getInputs that's presumably going to prompt the user, do some error checking, and then return 3 different values, X, Y, and Z. For example, maybe they're coordinates of a point in 3-dimensional space. So we call one function that gets the inputs. Then we're going to call a function calcstuff and pass these values, X, Y, and Z, to calcstuff, and that's going to calculate and return some result based on the inputs X, Y, and Z. And then the third step is going to display everything. So we have a third function called displayIt that's going to display all of the values X, Y, Z, and result. So this is our script that represents a modular outline of a program. So the script consists of 3 calls to functions, one that gets the inputs, one that uses them to calculate stuff, and one that doesn't calculate anything, but it just displays everything, presumably in a nice formatted way. So with just that amount of information, we can write the corresponding function headers. Not the definitions, but just the function headers. So our function that gets the inputs, notice we didn't pass anything to the function, so there are no input arguments, but the function is going to return 3 values, X, Y, and Z. So this is what our function header looks like. Our function calcstuff is going to receive the values of X, Y, and Z and use them to calculate a result. And our function displayIt is going to receive 4 input arguments, X, Y, Z, and result, and it's going to display them in some nice formatted way. So notice in that function header we don't have any output arguments because the function's not returning anything. It's just going to display all of the values from the script. So our program would consist of the script and then these 3 functions. Again, these are just the function headers. So one way that you can cut down on the total number of M files used is if you have the case in which one function is calling another, then you can make the one that is being called a subfunction. So both of them are stored in the same M file. So we have what's called the primary function, and that is stored in an M file with the same name as the primary function. the primary function body includes a call to the subfunction. So within the same M file, we have the subfunction. So notice it's the primary function in its entirety, followed by the subfunction in its entirety. So again, the subfunction is being called by the primary function, and so we can store them together in one M file. So the pro for that is that instead of two separate M files for the two functions, we can store them together in one M file and therefore cut down on the number of M files that we use altogether. The only thing that's bad about that is that the subfunction is only known to the primary function. So this function can only be called from the primary function up here. It could not be called from anywhere else, for example, the command window.